So this next article is great about memory management. JavaScript is an interpreted language, meaning it doesn't have a compiler, and because of that, you don't have to interact directly with memory because it comes with this thing called the garbage collector, which cleans up your messes that you make, which is quite useful. However, there are a lot of optimizations that you can do. We're gonna just touch base on a couple of them. So basically, it goes through the stack and the heap, talking about like what is stored where. One is about like static relationships, and the other one is about dynamic relationships. And you can see like when you create this class and you initialize it, you can see what happens, what is in the stack, what is in the heap. In all actuality, you don't really care. It's not that big of a deal for you to deal with. It doesn't really matter too much for what you're doing. Another thing to keep in mind is what is stored how. So when you have a string, so actually, a better way to do this would be to actually do this in here. So if I say let string equals hi, and let string 2 equals string, and I change the original string, so string equals test. What do we expect string 2 to be? So console.log string 2. Now I'm actually going to do string and string 2. Okay, so if I run this code, where's my terminal? Here we are. CD Code Academy. Okay, if I run this code, you can see that it says test hi. Okay, so string 2 was not affected by me reassigning string 1. So what if I do string dot to uppercase? What do we assume is going to happen now? Well, I am making string uppercase, right? So you'd assume that you'd have an uppercase hi. Well, that is not the that is not the case. Hi is not going to be uppercase, or string 1 is not going to be uppercase, because you cannot mutate a string because it is stored in the heap. And heap is static, right? Oh no, sorry, it's stored in the stack, and stack is static. Okay, so you cannot change numbers, you cannot change booleans, you cannot change strings, you cannot mutate those data types. However, if I have an object, and I can assign an object to be a const, so const object equals this, and I say object.foo equals bar, and I say const object2 equals object, my console.log object2. This case, it will actually change because object2 is directly, like, they are pointing at the same part in the heap. Okay, it's literally the same object. However, if I change object.foo to uppercase, that's not going to change anything. But if I say object.foo equals object.foo to uppercase, it will. Okay, notice how that's now capitalized. So how objects are stored in memory is important to understand, and this kind of goes through it. Wow, I'm yawning a lot. I don't understand why. So we can look at also releasing memory. So once you're done with the scope, the garbage collector will kick in and dereference things that you don't need anymore and stuff like that. And you can optimize this by doing having good practice in functional programming and object-oriented programming. If you do a good job in how you create functions and stuff, it'll make this a lot easier. So for example, you can see like memory closures. Because this function returns a function that references a large object, that object will always exist in memory as long as the function will exist in memory. So understanding, wow, I'm yawning a lot. Understanding like this is a really big thing. And this is very similar. If you have a set interval and you don't close the set interval, it's just going to continue forever. Okay. And especially if you are referencing something that's just going to increase or change, that thing will also always exist in memory. Okay. So again, this is a currying thing, and it's very similar to this thing. So now we have this interval and clear interval thing. Okay. You can use a DOM element to call clear. What? What do you mean by that? Okay, that statement does not make any sense. Okay, whatever. Yeah, and this is the same thing. If you have a callback, if you have like an event listener that a callback is looking at something that uses a lot of memory, it exists inside of this scope, meaning it's going to use a lot of memory. It's the same concept, okay? Next thing we already talked about, if we have an object and we reference that other object, it's going to change. Oh wait, no, this is something new. Sorry, that was from before. If you assign, you can create a circular reference. If I console.log this, oh whoops, it's going to see a circular reference, okay? Because if I do a.b, it's going to be inverted. That's going to be b. And so I can do a.b, a.b, and I can't do like b.b. That's going to be undefined, right? But I could do b.b equals b, and or make it even more confusing. b.b equals a, and actually no. b.b equals b, and a.a equals a. So now we have like a bunch of references, and it doesn't matter like which one I do, right? It'll always be referencing the same object, okay? This is generally just not good coding practice. However, the window in the DOM references itself. This is the window object. So if I do this equals window, or this equals this dot window, like it is possible, it is okay to do that, but do it, don't do it very often, and when you do it, be very mindful of how you do it, okay? Oh yeah, and if you use this is just general good practice for functional programming. Don't mutate state inside of an object or inside of a function. You should not be allowed to mutate state. That is a bad practice. So in this situation, this is a larger function, okay? Or this is actually might be referring to this. I think this is assuming greeting has already been declared and you're changing this. And this will leak into the global this. Although I'm not sure if that's true because function will creates a different this object. I'd have to actually run this. Yeah, I don't think that it's correct. Yeah, it's not quite right. This statement is incorrect from what I read. Yeah, so this dot greeting 2 does not mutate the global this because this is inside of a function. If this were an anonymous function, or instead of a constant, that would be true, right? It would actually mutate the global state. but this situation is not correct. That's just incorrect. I am bothered by them saying that. Come on, guys. You're literally teaching a course on JavaScript, and you have just blatantly false information on there. I mean, seriously. Come on. But that does raise another point. Okay, so say I have a let greeting. I have a function const make greeting. This is not good coding practice. Notice how it does say hello, and if I don't do this, it'll say hi. Okay, this is bad practice because the function is mutating something that, in my opinion, it shouldn't have access to in the first place, because this is a variable. Or if it does have access to it, it needs to be immutable. Okay, so you cannot change it. So it should only be read only. So that's just bad practice. If you're going to make a greeting, it should be return hello. Or I could have greeting. Now, if I make the same name, it forces me to only reference this one. And so even if I reassign it here, it won't change anything here. Like if I say greeting equals hello, this will still remain high, even though I'm reassigning it. Okay. So that's an important thing to make a distinguish between. So let's say I could return greeting equals hi question mark hello, otherwise sup. Okay, and then I can make greeting. This will remain high because I'm not reassigning it. Greeting equals this, and now this will be sup because I don't pass anything in, and now it'll be hello. Okay, but if it's anything else, really, it'll be this. Okay, so this is good practice because even if you're like changing something or like reading something inside of here, anything inside, any parameter that goes inside of a function or even a method should be immutable, right? Meaning it should not be changed. Actually, immutable technically means cannot be changed, but because it's JavaScript, should not be changed. Okay. You can't really make immutable. Well, you can. You can say const thing equals object dot freeze. This, and I say thing, or no. Const thing equals this object dot freeze thing dot foo equals bar console dot log thing. So in this instance, even if I reassign something, it'll break or it won't do anything. Okay, because thing is now immutable. It has changed from being in the stack, or sorry, being in the heap to being in the stack. It is. I'm pretty sure that's what's happening, or maybe not. I don't know. But no matter what I do, it will not change. And so even if I say that, it'll always be that. So that is one way to just freeze objects and make sure that there is no change in state of something. However, you shouldn't need that, because if you do good like practice, if you have a good paradigms and stuff like that, you're gonna be fine. You won't need it. But yeah, so all of this information is quite useful. You don't fully need to know this stuff because you don't deal with it directly. It's all under the hood. But this other stuff down here is useful. Okay, so yeah, memory.